just wake up on time. So as usual, on time I'm starting my class. Okay, I'm trying to take it into the morning time. But yes, let us see this question where it has been asked that what is the area of this shaded region. Okay, so here into this question, it has been given that a triangle ABC is a right angle triangle. This is A, this vertex is A, this is B, and this is C, right? So here, as per the question, it's given that ABC, triangle ABC is a right angle triangle, is a right angle triangle, right? It's a right angle triangle, then definitely just recall all the things which is coming into your mind for a right angle triangle. For a right angle triangle, we are applying the Pythagoras. One of the angle is 90 degree, and here it's given that right angle at A. So that means here this angle is given as 90 degree. This one is given as 90 degree, right? Now, for the right angle triangle, the other things which are coming into your mind is that base square plus perpendicular square will be equal to hypotenuse square, right? If this is 90 degree, then opposite to it will be the hypotenuse, right? So BC can be calculated, right? Just think, I'm just speaking for the right angle triangle ABC. So on one of the, let us say if AB is the base, on this base a semicircle is drawn. Okay, let me read out the question first. In the given figure, triangle ABC is a right angle triangle at A. Semicircles are drawn on the three edges AB, AC, and BC. So three semicircles are drawn. Semicircle on edges edges of the triangle AB, BC, and AC. So on all the three sides, semicircles are drawn, right? Now, on based upon that, it is given that AB is equal to 3, S this one, AC is equal to 4 cm. Find the area of the shaded region. So this is the shaded region. This is a semicircle, and AB is the diameter and AC is the diameter for the shaded, for the not for the shaded but for the semicircle drawn on it. Okay, so if these are the two semicircles, then what is the radius of these two semicircles? Just find out the area of these two semicircles separately, and from this subtract the area of these this triangle, right? Then you will get the area which consists of this one. Okay, this vacant space, but this should not be like that. Okay, so what we will do, we will simply first of all find the length of BC, because BC is not known to you. Just apply the Pythagoras and you get the length of as BC as equal to root over of 4a square plus 3a square by applying the Pythagoras, which is coming as 16 plus 9 25 root 25, which is coming as equal to 5. So BC is calculated as 5. Now if BC is calculated as 5, then what is the radius of this semicircle? The semicircle in white, this one, this will be 5 by 2. This radius, it will be equal to 5 by 2, right? So whatever the total area is, we need to reduce this, we need to subtract the semicircle's area which is in white. Okay, so what we will do, we will simply calculate the area of the bigger semicircle, this one. Okay, so area of semicircle with base BC or with diameter BC, right? Where diameter BC, let me write diameter equal to BC and radius equal to diameter BC by 2, which is coming as 5 by 2, right? So this will be the, let us say if O will be there into the center, then OC is equal to the radius of the bigger semicircle. Okay, so the area of this semicircle with a diameter BC, with a diameter BC, right, this one can be written as equal to pi into r square, that is 5 by 2 is the radius, right? This is the area of this circle, but it's a semicircle, so this will be divided by 2. So this is the area of this white semicircle, which is built upon the one of the hypotenuse of this right angle triangle ABC, where BC, the hypotenuse, is acting as a diameter, right? Dia BC, radius this, and this is the area of that semicircle, that is pi by 2 into 5 by 2 whole square, this one, right? Now we have calculated the area of this semicircle. Now what we will do, why don't you just calculate the area of this triangle and these two semicircles on the top. If you calculate the area of this triangle, let us say triangle is 1, right? This one, the triangle, the right angle triangle I am saying, into the center, this is 1, and the two semicircles on the two edges, that is base and perpendicular, are the area number, this is area number 2, and this will be the area number 3, this entire one, this is area number 3. If you add the area of this triangle plus area of the semicircle plus the area of the semicircle, I am saying the semicircle with the shaded area and with this white area entire, okay, then triangle area, that is area of triangle plus semicircular area, semicircle area, that is area of region 2, this is region 2 I am saying, plus semicircle area of region 3, right? When you add all this, okay, this is area 1, this is area 2, this one entire semicircle, okay, area 2, and this is area 3. If you add this area and this area, you will get the area of the entire figure, isn't it? Tell me. So this will be the 1 plus 2 plus 3, okay, all this need to be added, and all this will give you area 1 plus 2 plus 3, this will give you the total area of the figure, isn't it? Tell me. This entire figure, which is two-dimensional figure, which is in front of you, this consists of this semicircle and a triangle in between. So that's why what I did, I simply I simply just uh, this dotted area, the triangle, this one, right? This is area number one, right? The triangle. That's why I mentioned triangle, right? Then semicircle, this area 2. Semicircle, don't confuse with area 2, that only the shaded one. But this shaded plus this white portion, which is above the line AB. Okay. All the area above the line AB is the area 2. I mean to say this is line AB, okay, and this area which you are able to see, this is area number 2. Similarly, all the area above AC, right? This one, whatever you are able to see, this is area 3, right? So area 1 plus area 2 plus area 3. That means all these three areas will add together, and this will give you the total area, isn't it? Tell me, my dear friends. If this total area is calculated, and from this, the area of the semicircle, which is built upon the hypotenuse BC, if that area will be subtracted, or not, you get the area of the shaded region, right? So from this, subtract total from this total area of the semicircle drawn on BC need to be subtracted, right? This minus, this is minus, that means this area, that is area of the semicircle built upon the base BC or hypotenuse BC with OC as radius, right? And that is coming as pi by 2 multiplied by 5 by 2 whole square, right? This is the area of this semicircle, right? If this area is subtracted from the whole area, or not, you get didn't I think you get the area of this shaded region, isn't it? Tell me, area of this shaded region will get it. From the total area, if you subtract the area of this semicircle, that is from the total area, if you subtract the area of the semicircle which is built upon the base BC or hypotenuse BC, where OC is the radius of that semicircle, then you will get the shaded area, right? Then you get the shaded area, my dear friends, right? This shaded area. So I want to find the area of this triangle. Area of this triangle is half into base into height. So it will be coming as area of this triangle. The first part is half into base. Base will be 3 and height will be 4. This is area number 1. This is first area, half into 3 into 4. So this is coming as, just solve it, 40 12 by 2 6. So 6 centimeter square, right? Because units over here is centimeter. It's written into the description of the question, but not here. So area of this triangle, the area of this triangle is half into 3 into 4, that is coming as 6 centimeter square. What is the second area? I'm just calculating the total area, total, okay? So the second part of this figure is the semicircle which is drawn on the as a diameter AB, okay? So area of that second part, which I have written over here, semicircle, right? Semicircle drawn on AB, right? Is how much? Here you can see 3 is the length of the base of this right angle triangle. Then this radius will be here radius 1 will be, if it is 3, it will be 3 by 2, isn't it? 3 by 2, it will be 3 by 2. So the second area is calculated as pi r square, where radius will be 3 by 2, because 3 is the length of AB, this one, right? 3 is the length of AB, then this radius will be 3 by 2, right? So this will be coming as half of the area of the semicircle, that is equal to pi r square. Half of the area of the circle, that is equal to pi r square, not semicircle. If you divide it by 2, it already become a semicircle, right? So into pi into 3 by 2 whole square, right? So this will be coming as pi by 2 into 3 by 2 is 1.5, 3 by 2 is 1.5, 1.5 whole square, 15 15 225, so it will be 2.25, right? This is area number 2, right? Now what is area third? The third area is the area of the semicircle which is built upon the diameter AC, right? This is having dia AC, right? Semicircle 2 is having dia as AB, right? So we need to understand this. Then what we are doing, we are calculating the total area now. So a first area is 6 centimeter square, second area is this one, right? Now what is the third area? This one, the third area. This will be the semicircle built upon the diameter AC, right? The diameter over here is AC. We already calculated the area of the triangle on diameter AB, right? So area of the semicircle drawn on the diameter AC is equal to the area 3. This will be the area 3, and area 3 will be nothing but half of the area of the circle being considered on the diameter, built upon the diameter AC. So half of pi into r square. R will be here, 4 is the length of AC, then this radius will be 4 by 2, isn't it? This radius will be 4 by 2 because AC is the diameter, right? So it will be 4 by 2 whole square, and this is coming as pi by 2 into 4 by 2 is 2, 2 square is 4, pi by 2 into 4, right? So add the area 1, add the area 2, and add the area 3 all together will give you this total area, this total area. Why I mean to say, once you calculate this total area, we already find it out. Just solve it and add it. This will give you the total area. And from this total area, subtract the area of the semicircle which is drawn on the hypotenuse BC. Right? So just solve it and get the total area. Okay. So this will be coming as, I'm just shifting a little more. Okay. Now this will be coming as, right, when you add area number 1 2 3, just add it, right? Then you will get this 6 area of the triangle, this one, this 6 plus this one, second area and third area, that means both the semicircles area, that is pi by 2 into 2.25 plus pi by 2 into 4 Why don't you take pi by 2 as common? Then it will be 2.25 plus 4 into the bracket. So this is the total area which is calculated for the entire figure which is in front of you. Entire figure. Okay, the total area is coming as this one. From this, subtract. What you need to subtract? Area of this semicircle. The semicircle drawn on the hypotenuse BC, and that area is pi by 2 into 5 by 2 whole square, right? So subtract from here. Subtract from here, right? So this will be pi by 2 into 5 by 2 whole square, which will be subtracted. That is pi by 2 into 5 by 2 whole square. 5 by 2 is 2.5, right? 2.5 whole square, 25 into 25, 625. So it will be 6.25, because decimal will be coming after two places from right, right? So this will be the area of the shaded region. This is the shaded region which area is calculated. How? Calculate the entire area, and from the entire area subtract the area of the semicircle which is in white color, right? Which is not colored, right? So this will be coming as just simple solve it. Okay, so this will be coming as area 1 2 3 added together. This will be this one minus 5 by 2 into 6.5. You can see 6, simple calculation I am doing. 6 plus pi by 2, 4 plus 2.25 is 6.25, right? And minus pi by 2 into 6.25. Oh my god, this entire term pi by 2 into 6.25, and here pi by 2 into 6.25, both will be cancelled, because you can see plus and minus sign. So this will be cancelled, right? And we get the shaded area as 6, right? So this will give you the shaded area as 6 centimeter square, which is the shaded area. Which shaded area? Let me squeeze a little so that you can easily understand the entire page. This is the shaded area. The shaded area is calculated, and that is coming as equal to 6 centimeter square. So my dear friends, 6 centimeter square is the shaded area for the question which we've taken up for today, right? 6 centimeter square. 6 centimeter square is the shaded area. So let me write area of the shaded area, this one plus this, both will be coming as equal to 6 centimeter square, which we have solved it over here, right? And in this way we have solved this question, my dear friends. Thank you for watching. Be connected, happy learning, take care of yourself, and I will come up with a separate session again with some conceptual discussions, and I always welcome your thoughts through the chat. Just be connected, take care, bye bye, see you into the next class.